Alright, here goes a video on graphing rational functions. Now rational functions, they're functions in the form of maybe f of x is equal to g of x over h of x. We'll just make that up. Where g and h are both different functions, and we're going to divide those functions. Okay? So we're going to just consider what the rational function y is equal to 1 over x. And what I want you to do is just think for a moment about a couple of these questions. First of all, what are your possible values of x? Well, x can be anything it wants to be, except x cannot equal 0. And I'm sure you know why, and that's because you can't divide by 0. That's something you already know. There's no 0 in a denominator. So the possible values for x are anything except that. It can be a positive number, it can be a negative number, it could be a decimal, it could be a fraction, it can be an integer, anything it wants to be, except for 0. So, as positive values of x increase, what happens to the value of y? So, let's think about that. Y is equal to 1 over 1. And then we'll say 1 over 2. And then you say 1 over 3. And then we skip a few and say 1 over 10. What's happening to y? As x increases, well, y is getting smaller. Or we can say decreasing. So let's go backwards. Describe what happens to y if positive values of x are less than 1. So as x is getting smaller. So think about this. Y is equal to 1 over 1. And then 1 over 1/2, which we know is 2. And then 1 over 1/4, which we know is 4. We know that y is getting bigger. So think about that for a moment. Make a sketch of a graph what you think it'll look like, and be sure to include the negative x values as well. So if we were to take a graph, what do you think it would look like? So I'm going to give you a moment to think about that on your own, and if you thought that it might look like this, you would be correct. That's the shape, because look, as x increases, remember, y gets smaller. As x gets smaller, but still positive, we said it got bigger. And of course, that would happen in the negative zone as well. So that's exactly what these are going to look like. And the shape of this is called the hyperbola. And the symmetrical parts are called branches. So this is what our graphs are going to look like in this chapter. And again, they're called hyperbolas. Not like the conic section hyperbola, but they're still called hyperbolas. So what are we going to talk about? Well, while we graph these, we're going to have asymptotes. And an asymptote is defined as a line. And just so you know, we're going to graph those dashed. That represents, we'll say, impossible values. Okay, the asymptotes of this graph are, and we're going to talk about y. So remember what we said. We said that x is not allowed to be 0. So graphically, what we would do is we would go to x equals 0 and we would graph a vertical line. Okay, that is one of our asymptotes. Our vertical asymptote represents x cannot equal 0. So our vertical asymptote is actually x equals 0. That's the vertical line that represents the impossible values for x. Okay, so now we got to think a little bit about y, our horizontal asymptote. So our horizontal asymptote, y cannot equal what value? So think about it. Can you think of any values that y will never be? Well, for this particular problem, y will never be 0 either, because it's 1 divided by a number. So what can you divide 1 by to get 0? And the answer is nothing. You can't divide 1 to get 0. So our horizontal asymptote, the equation is y equals 0, where we would graph a horizontal line at y equals 0. And from there, all you have to do is use your graphing calculator to sketch this graph. Okay, that's what you're going to need to do, is use a graphing calculator to sketch it. So all you have to do is go to your get your graphing calculator, and in y1 you just have to type 1 divided by x and see what it looks like. But an easy way to do it would be to just press second graph and look at the table of values and plot a few points to see what it looks like. So I'll do that here for you. And it should look a little bit like that. Again, just press second table. You'll look at a few values. This one's pretty difficult to graph because really the only nice coordinate is 1, 1 and -1, -1. Because if you think about it, once you get to x equals 2, you're already at 1/2, and all the rest of these are going to get smaller and smaller. So, but that's it. You just use your graphing calculator to find the graph. I'm not going to make you graph these by hand. I will expect you to be able to graph your vertical and horizontal asymptotes by hand. You shouldn't need a calculator for that, but the actual hyperbola part of the graph, just use your graphing calculator. So there's two forms in which these functions can occur. One form would look like this, where we have y is equal to a over x minus h, and then we have our plus k off to the side. So you're going to have your vertical asymptote, and all you have to do for that is x equals h. Or you would just set your denominator equal to 0 and solve. So that's where your vertical asymptote is going to be. Your horizontal asymptote is going to be whatever that k value is off to the side. So y is equal to k. So our vertical asymptote, again in this example, is x minus 6 is equal to 0. So x equals 6. That is your vertical asymptote. So x equals 6. Our horizontal asymptote is the -3 off to the side. That's y equals -3. So graphically, we're going to go put those down now. So we go to x equals 6, and we're going to do a vertical. Remember, it's a dashed vertical line. Asymptotes represents values that cannot exist, so that's why we do not make them solid lines. And we have our y equals -3. And those are our asymptotes. So from here, you just need to state your domain. Your domain is x cannot equal whatever your vertical asymptote is. So domain is just like stating what x can or cannot be. Same with the range. Range is going to state what y can or cannot be. So y can be any number it wants to be except for your horizontal asymptote. So y is not allowed to equal a -3. Okay, so for domain, x cannot equal your vertical asymptote. Your range, y cannot equal your horizontal asymptote. That's as easy as that. So again, to graph this, you're going to have to go use your graphing calculator. You're going to want to go to y1, and you want to be very careful when you type this into your calculator. I like to say you should keep your fractions together. So we have our fraction for this big 4 over x minus 6. So our numerator is 4 divided by, now our denominator needs its own set of parentheses, so it's x minus 6 in parentheses. So there's your denominator, and there's your first fraction. And now we have our -3 on the end. And go press graph or press second table and see what you're going to get and copy it down onto the graph using nice coordinates. So go right ahead and do that. And if you copy down a few nice points, your graph should look like this. If you, again, type it in the calculator correctly and use second graph, the table, you should have seen points like 8, -1, 7, 1, 10, -2, and you also should have 4, -5, 2, -4, and 5, -7. Those points all worked out really nice, so you just transfer those and sketch the graph. Remember, I'm not looking for perfection here. I do not want your graph crossing over your asymptotes because Well, that's not what it's supposed to do, so don't do it. The other form is when you have something that looks like this. So we have rational functions where we have ax plus b for your numerator and cx plus d. These are also hyperbolas, and for this, the vertical asymptote again occurs with what makes the denominator 0. So you're still going to be setting the denominator equal to 0 and solve. And the horizontal asymptote for this, you just take your leading coefficients of x and you write them as a ratio. Okay, so for this example, the vertical asymptote, we would just set 3x plus 3 and set it equal to 0, and 3x is equal to 3, so x is equal to 1. So that is your vertical asymptote, x equals 1. And if you remember correctly, x cannot equal 1 would be your domain. Now your range and your horizontal asymptote, this is 1x over 3x, and you just take the leading coefficients. So our horizontal asymptote is y equals 1/3, which means our range is going to be y cannot equal 1/3. And again, the graph is the exact same. You have a vertical asymptote at x equals 1, so you go to 1. It's a vertical dashed line. And then for y, we go to y is equal to 1/3, so barely above the x-axis. And we have that. And then in your graphing calculator, you're going to need to type into y1. This is an example where you don't have anything off to the side, so it's a little bit easier. You just type your numerator in parentheses, x minus 2, and then divide by, now you type your denominator in parentheses. And then you just go press graph, take a look at what the graph looks like, press second graph and look at the table, plot a couple of nice values if possible, and then just sketch the graph, which should look a little bit like this. So again, none of the points really worked out very nice in this one, so for this it's pretty simple to just go right ahead, sketch your graph, as long as you're not crossing over your asymptotes, and if it looks pretty reasonable, you are good to go. Alright, most important part about this is being able to state your asymptotes and your domain and range, and then your calculator will do the rest of the work for the graphing part. Alright, this is Longo and I'm out. See you, bye.